What's in Fy? No, it should be 3x squared. Abi? Okay, s cube. How was I wrote now? Abi? In this place. Yeah, Abi. Okay. That's xy. xy. Abi? Good. Calm down. Abi? Okay, good. Carry this answer. What's the other one? 3 4x plus what? 31. 3 equals to 4x. Abi? Plus 2 minus 2x. Abi? This one to the other side. This is 1. Abi? Also 2x. Yes or no? And here x equals to what? Half. I show. And if x equals to 1 over 2, where should I put it? Put it back here. 2 minus 2 1 over 2 equals what? 3y. 1. Abi? 2 minus 1 equals to what? 3. Abi now? So what is my fxx here? So fxx, please let me check, please. 6xy squared, and that's 12x squared y squared minus 6xy cube. Is that all? So here put x equals to what? 1 over 2 and y equals to 1 over 3. What's your fx now? 6 1 over 2 1 over 9 minus 12 1 over 4 1 over 9 minus 6 1 over 2 1 over 3 minus 1 over 3 minus 1 over 9. Abi? The greater than 0, Abi? The greater than 0, Abi? Abi now? So if it's greater than 0, what of the fx's? If it's lesser? Abi now? That one is lesser, this one too is lesser. You can call this thing, it's not a relationship. Oh. And even if I square, you still give me a positive answer. You give me a positive answer. The thing that exists between them is not a relationship, but that thing is local maximum. Write it down. Oh yeah. Everyone to write. Oh yeah, just stand up and let the next person come, please. I should go. So, good evening everyone. Binomial expansion. I thought some persons in the morning and look as if they said I thought in the morning are not even present tonight, so a good thing. If you're here in the morning, raise up your hand. Apart from you, no one else was. Okay, good. Let's go over it. Let's go over the course once again. Binomial expansion. Already. This is the mathematical approach. You can write it down. Let's give the definition. This is a mathematical approach. Are we together? That is used specifically in the expansion of two different terms. Are we there? That is used in the expansion of what? Two different terms. Are we together? So what it means is that, let me just explain it. So far so good. If you have probably two terms written in such a way that you want to expand them, the best way for you to use to expand them comes from what? Binomial what? Expansion. Do you understand that? Okay, good. And I want to tell you that the word binomial comes from the word two. Yes or no? That means the maximum number of times you'll be expanding in a binomial expansion will be what? With 2 times. I get what I'm trying to say like that. Just know in the back of your mind that if you want to expand terms, the best way to go through those terms is through what? Binomial expansions. Do we understand? Are you sure? Alright, good. Now, first up, there are 2 methods or 2 methodology in binomial expansion. There are 2 methodology in what? In binomial expansion. There are 2 methodology in binomial expansion. Okay. Now, first one is the usage of the Pascal triangle. My first one is what? The usage of the what? Pascal triangle. And second one is the usage of combinations. What do I call it? Usage of what? Combinations. Let's go over it again. There are 2 ways to what? There are 2 methods of approach to what? Binomial expansion. The first way is to what? Pascal triangle. And second way is to what? Like one set of combinations. Okay. Let's pick them one by one. Now, let's explain how to use the concept of a binomial expansion. Are we together? So let's use the first one, Pascal triangle. And since you are dealing with Pascal triangle, I would love to sketch a Pascal triangle for you, at least for the first 7 times. This is 6 times. For the first 5 times. Now, what do we use Pascal triangles for? Let me explain the concept. So, not for example, let's take this for an instance. Let's say you want to expand a plus b all squared. Are we together? How do you expand this all squared? Normally, it'd be like a plus b. Yes or no? And for me, I can now have a squared plus ab plus b squared. And at the end of the day, you can now have squared plus 2ab plus b squared. Where this one is 1, where this one is 1. And number in between there is 2. Yes or no? Now, Pascal triangle helps in computing the coefficient of your what? Expansion. I'll get my point like that. So Pascal triangle will do what? They help in helping you compute the what? Coefficient of your what? Expansion. For example, 1, 2, 1 here is the same thing as what? The 1, 2, 1 that you have here. Yes or no? That means if you want to compute, an expansion and you don't know how, the best way to go through is what? Go through for what? Pascal triangle. I hope you get what I'm trying to like that. Good. Now for each expansion you want to get, all the coefficients in these terms will give you the expansion. Yes or no? Good. And another thing I wanted to know is this. In coefficient in binomial expansion, the increase of one causes to the decrease of other. What I say, the increase of one equals to the decrease of other in binomial expansion. And most of the time, it is always this thing, this thing here that increase, while this decrease, this increase. I guess what I'm trying to say like that. And again, that's another thing I want you to note. Another last thing I wanted to notice is that in a binomial expansion, getting it, the power of both of your variables must always add up to the number of powers you are coming from. Don't do one approach like that. For example, probably we're expanding a plus b raised to power 26. I get to my approach. You know that in this expansion you have different terms in it. I get to my approach that different terms in it, different powers in it, yes or no? Now, in a binomial expansion, all the powers of the terms you are having, when you add them up together, they must not be greater than this your original power. Is that clear? Is that clear? Okay, good. So let's do some expansions. Yes, sir. Yes, it mustn't be greater than. The thing is that they must not be greater than, and at the same time they must be equal to. Are we together? Now I want to. Oh, no. Yes, sir. Yes, sir. Sir? Can we use any what? Values like I don't get. It's like a constant rule. This is how it must be. No other values can generate this. You know, my parents say like that. This is how it must be. I guess my parents say like that. Are we there? The thing now that I want to explain now is, so want to know how to use that Pascal triangle to our what? To our own usage. Now, expand the following. That is subheading. Or better still, find the expansion of the following. Find the expansion of the following. Are we together?
Yes, sir.
Number 1. A plus bx. No, or just say a plus b, yeah. Number 1, a plus b raised to power, that's everything. A plus b close bracket, everything raised to power 7. Number 2, 2a plus 3b, everything raised to power 5. Number 2. Number 3, 3 minus 2a, 3 minus 2a, 3 minus 2a raised to power 4. Next one. That's number what? Next one. 2x minus 7y raised to power 8. Abby? Number what?
5.
I want to call number 5 now. 1 over 2x. Okay. 1 over 2x minus 3 over 4y minus 3 over 4y. Are we there? Everything is power 4. Are we there? Okay, so let me get a duster to clean so that we can know how to use them. Okay, let's start. What's number 1? Are we together, please? Please note that whatever you have on your Pascal triangles are not real values. They are what? Coefficient. What do I call them? Coefficient. And what are coefficients? Coefficients are numbers on top of your variables. Yes or no? Right, good. So let's talk about that here. Now, what's your first coefficient there? 1. Have we now? Then you have a raised to the power 7. Are you getting me? Now, from your first coefficient, the first time your first coefficient gets the what? The highest mark of your what? Of your power. Then you start reducing those marks from the second down to the what? To the end. Are we together? Then from here, what will I have? What's the next coefficient? 7. Now, instead of this, I have what? A raised to the power 6. Then at a raised to the power 6, I will have what? B raised to the power 1. Are we getting it, please? Then plus the next one is what? What's the next term, please? 21. A raised to the power what? A raised to the power 5. B squared. Then plus what? 35. A raised to the power 4. B4 plus 30. Plus 5. A raised to the power 3. B raised to the power 4. Okay, B raised to the power 3, yeah. Are we together? Then plus what's the next time here? 21 a squared b raised to the power 5 plus what? 7. Plus 7 a raised to the power what? A raised to the power 1 b raised to the power 6 plus what? 1 b raised to the power what? 7. So you're gonna trying to say now. I have successfully expanded what? This equation that I have here. Are we together? Now I want to write it very well without my necessary signs. I don't want to write the signs where I don't have them. So here I can have something like this, which is a raised to the power 7 altogether plus what? 7 a raised to the power 6b, right? Plus 21 a 5 b squared altogether plus 35 a 4 b cube plus 35 a cube b4 plus 21 a square b5 plus 7 a b6 plus b7. Do you understand? Do you understand? I have completely computed the first part. Now the second part. What's in the second part? Call the second question for me. It's power 5. Which expansion will I go and use? I'll go and use the expansion of the power of 5. Yes or no? Good. Now, everything here, see like the same thing I see. Everything here can take the maximum power of what? Of 5. I'll get one apprentice like that. So for me, what can I have? I will have 2a, everything is power 5. Are we together? Plus, what's the next term here? 5. No. Coefficient is 5. Are we together? 2a raised to the power 4. Then you have your 3b. Are we together? Are we together? Then plus what's name? Then 2 raised to the power what? 3. 3b raised to the power what? 2. Are we together? Then plus the next one is what? 10, which is 2a raised to the power 2. 3b raised to the power 3. Are we now? Then plus the next time 5, 2a raised to the power 1 and 3b raised to the power 4. Then plus your last time, which is what? 1, and that's what? 3b raised to the power 5. Do you understand, please? Do you understand? Now, so from here to now compute this value, I start by saying this: 2 raised to the power 5. You can press it on your calculator. I'll give you 32 a raised to the power 5. I'm getting it now. Plus, let me get my calculator. So if you have a calculator, you can help me deal with the calculator. Are you getting what I'm saying, please? So what do I have here? I have 2 raised to the power 4 times 5 times 3, which is what? 240. Yes or no? 5 times 16 times 3. That'll give me what? 240. What will I have here? A raised to the power 4b. Are you seeing it, please? Then plus what do I have here? Now I have 10 times 80 times 80 times 90. Yes or no? 10 times 8 times 9. So here I have 720. Yes or no? Now I have a cube b squared plus what is next time here? I have 10 times 2 times times 4 times 7. So I have 1080 a square b cube. Yes or no? Then plus the last one as 810 a b4 plus 243 b raised to the power 5. Do you understand, please? Do you understand? Okay, what's the next question? You have 3 minus everything here is your a, everything is your b. Are we together? Let's start our expansion. So what do I start from? 3 raised to the power 4, right? Plus what's the next number that I'll call? What's the next number that I'll call? 4. Then what will I say to them? 3 raised to the power 3 and minus 2a. I get in it. And plus the next term there is 6 raised to the power 3 raised to the power 2, and you can ask minus 2a. Are you busy? Are you getting me? Yeah? Plus what's the next one? 4. And you ask me again, this time 3 raised to the power 1, and you tell him it is what? Very, very urgent. Then the last time here you call him, which will be minus 2a raised to the power 3. I will get to what? It's power 4. Yes or no? So from here, let's now do it, the expansion again. So from here, 3 raised to the power 4 is what? 81 plus 4 times, this is 3 raised to the power 3. Yes or no? Good. 6, There's no keyboard. Okay, there's no A in it. Okay. The answer should just be A or B. Okay, good. Thank you. And 6 times 9 times 4 plus what? 216 A raised to the power what? A raised to the power what? 2 minus AB. 4 times 3 times 8 minus 96 raised to the power A. Are we together? Plus what? 2 raised to the power 4 will give you what? 16a 3 raised to the power 4. Do you understand? It can be minus. The reason why it can be minus is because you have a minus squared here. And a minus squared will give you what? A positive number. Should you understand? That's your final answer for that side. Number 4. What is question number 4? 2x minus 7y raised to the power what? 8. I'm not taught you 8. Change this 1 to 6. She gets, I'm not taught you power of 8. Change it to power of what? Of 6. So what do I have here? 2x raised to the power what? 6. Then plus, in the first system I did 6 2x raised to the power what? 5. What is the next step I have here? Minus 7y. Yes or no? Then plus the next person is what? Next one is what? 15, Abby. How together? And what is after 15? What do I have? 2x raised to power what? 4. What do I have here? Y squared. Put together. Then plus what? 20. What do I have here? 2x raised to power 3, right? Minus 7y raised to power. Happy now? Are you still happy? Okay, the next time. Plus 15, Abby. 2x raised to power 2 minus 7y 4. Are we together? Then plus 6 2x raised to power 1 minus 7y raised to power 5. Are we together? Then plus what? Plus 1. Now this plus, it should be plus 1. It should be plus minus 7y raised to power what? 6. Should you understand? Huh? From here, let's start. 2 raised to power 6 will give me what? 64. Abi? X raised to power 6 minus 6 times 2 is power 5 times 7. That's 1344 x 5 y all together. Then plus hmm? 11760 Abi x is power 4 y squared. And the next one here is minus 54880 x cube y cube Abi. Then plus what I have here, one four four 060. What do I have here? X squared y raised to power what? 5. Yes or no? Is it plus here or what? Minus okay. Yeah. What is this one? This one here. 6 times 2. Two and 1, Abi. Abi. Oh, there's 5 here now. Do you understand, please? Okay. Last one. This for what? What do I have? Abi? 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 Abi now? Hmm? Where? Eh. And now 4 times 1 over 8. Then 4 times 1 over 8 times minus 3 over 4 now. Which one? I don't get. This one here. It should be what? Why? 4 times 1 over 8 is what? And let's write quickly. Let's try to ask this one.